And we're recording. Okay. Triangles have very specific rules in how we name them and how we label them. Hopefully you guys have seen this before, so hopefully this won't take very long to get across to you. Okay? The first thing you got to know is these have a proper name. What are they? Bill? Yes, they are vertices. Vertices, which in English is a corner. Vertices. How do we label them? Capital letters for labeling. Everybody knew that? Okay. So this triangle is named A, B, C. Could I name the triangle BCA? Could I name the triangle CBA? Could I name the triangle ACB? Yes. I can name it anything I want as long as I go vertex to vertex to vertex. Everybody cool? All right. Now, if I wish to compare this triangle to a similar triangle, we're going to talk about similar triangles in a minute, I use the similar sign. Now, this is key. Since this guy is named A, B, C, A, then along the longest side to B, then up to C, what do I have to name this triangle? FED. FED. Because order matters. Is everyone cool with that? That shouldn't be news to anyone. Is that news to anyone? Be honest. No? Okay. Even if it was news to you, you get it now, right? You just follow the same order. Okay? Everybody cool? All right. Now, do you know how we name sides? The sides of the triangle. With the same letters, but there's a special order. Again, I'm going to use red to do the sides. I know that it doesn't really show up as red up there. I'm sorry. The new projector is coming still. Sides are labeled lowercase. I'm lazy. I know that it's supposed to be lowercase. I'm going to say small letters. And here's the key. They are named for the vertex opposite. Now, I told you yesterday, what does opposite in this unit mean? Across. So what is the name of this side right here? Little c. Everybody got it? Because it is across from big C. Cool? Now, up until this year, you probably named the side from the corners, right? You guys probably called this AB or BA, but now I want to start calling it by the lowercase c. Is everybody cool with that? So what does that make this side? Little a. And what does that make this side? Little b. Everybody cool? Everybody gets it? Yeah? Okay. Next thing. Fill this one in and name him. So what's this guy down here? Lil D. What's this guy? Lil F. What's this guy? Lil E. Got it? I used to have a girlfriend whose name was Lilith. And before she was my girlfriend, I knew her for years and years and years. When we were little kids, back when boys still bugged girls that they liked, some of the boys in your lives haven't grown out of that, and they will continue to bug you girls when they like you, but some of them will have grown out of it. And it's around now that guys start figuring it out. But we were friends before, and I realized while we were friends that, man, I really like this girl, so I'm going to bug her. And her name was Lilith, L-I-L, Lilith. But I called her Lil-ith, Little-ith. She hated that. I thought that would help me out later in life. Fortunately, it did, but not because of me calling her that, because she was one of those, and some of you may have had these, where you go to the same place in the summer every year, and the same people are there, and eventually you realize, hey, wait a minute, we've been growing up together, maybe we should kiss? I don't know if that happened to any of you, but it happened to me. And she was my summer girlfriend, because, I had a girlfriend at school, but then I went away for summer, and then I had a new girlfriend. That was Lilith. That really made Tamara angry. But I thought it was okay. School girlfriend, summer girlfriend. They were never going to meet. Anyways, long story short, Lilith ended up being the girlfriend that stayed around, and Tamara no longer was girlfriend. She was not happy about the situation. How did you find out? I think Eric Mitchell told her. Because here's the thing. Eric Mitchell had a girlfriend. Her name was Colette. She came to visit where I go in the summer. And Colette I had also known my whole life. And Lilith was away, and Colette and I were hanging out on the beach watching stars. And, you smooch under the stars. And then Colette told Eric, and Eric was mad. So Eric told Tamara that I was dating Lilith, because he was mad that I kissed Colette when he was supposed to be with Colette. So Tamara found out about Lilith, and Tamara sent me packing, but Lilith was okay with it. But then I didn't see her again until like 2 years later when I went to UVic, because she lived in Victoria. So when I went to Victoria, I was like, oh, Lilith lives in Victoria. And then it all started up again.
It's a love pentagon.
Running the program, am I right? I know. Anyway, I recorded all of that. So when you watch this with your folks, which you won't, I know, but that's beside the point. Okay. Yes, Scarlett? Oh, Catherine. Totally different. Although Catherine knows Tamara.
Oh.
And Colette. But she doesn't know Lil. Oh yeah, she knows all about you. Never mind. It's another story for another day. Lil has a long and involved saga through my life. It's like a movie, like a bad movie. She keeps coming in and out of my life. And, oh, that sounded awful. She shows up in my life. She hasn't shown up in a few years. But on her last show up, she decided that she didn't like me anymore, but she liked my buddy, whose name was Gene. A couple of girls that used to be my girlfriend ended up liking Gene. I really don't know why that happened, but ironically, Catherine has never thought Gene the tiniest bit attractive. So I don't know. Anyways, math. You guys, yeah, I know, it's tough to name the shape. It's not a love triangle, it's a love dodecahedron. A dodecahedron is like a 12-sided figure, I think. I stopped caring at nonagon or decagon, because after that, really, a 10-sided figure, what am I, a D&D player? Because the dice have so many sides on them in Dungeons & Dragons. Not that I would know. It's a bit of a geek check. Maybe I would know. Dungeons & Dragons, geeky dice rolling game. The Dungeon Master, you've come across a dryad. If you don't roll 20, she will slice your head off your shoulders. I cast my spell of protection. Roll 7. Yes. Dungeons & Dragons. We're good here, yes? Okay. On your next page, actually, wait, maybe there's more I want to say about this. No, because you guys are honors kids. You're cool, yeah? No, there is something more I want to say about this page. How many of you carry a ruler to class? Yeah, a geometry ruler. Yeah, it can be a little one, doesn't have to be a big one. How many of you have a ruler about you? Like right now, not in your locker. You have it on you. Yeah? Okay. I might have some more. If I do, I'm going to get you guys to do something. It's not walk back and say hello to Tricia.
I left it at home.
I want you to measure triangles like the trundle wheels. 3 centimeters. 2 centimeters.
Can you go get my water bottle?
Hey, there's my rulers. I knew I had a stash. Huh? Math. What do you think we're doing? You've been in this class before. Sometimes you learn stuff about my life and you don't necessarily need to know about it. You've heard the story of my girlfriend Lilith.
Oh, yeah?
See? Well, we just talked about Lilith. Huh? I know you have. They just heard the Lilith story. Well, Lilith, well, you never heard the long Lilith. There's other girls in the Lilith story that you never heard. They got yeah,
you should.
Okay. Take a measuring device. If you have one, lovely. If you don't, no biggie. And on the next page, just do the lengths of each side, okay? And fill in that chart. Because I know none of you are carrying a protractor, so don't worry about the angles. Don't, really? Geek check. You want to play some Dungeons and Dragons later? I got a D20. All right, a dice with 20 sides on it. Everybody, who doesn't have a D20 just in case of an emergency? You know what's funny? You can get an app, which I have on my phone, that you can set the dice you want. I can roll 20 D20s if I want on my phone screen. And they're in 3D and wonderfully rendered. Anyway, grab a ruler, measure the sides, fill in the chart. Go.
Dude, I hate it.
Other people, if you have your own ruler, use it. Oh, look, Tiffany's got like 3 rulers there. She's like the measuring guru.
Is there no more?
I don't think so. You could have a tape measure. It's only got inches, though. Yeah, please. Yeah. And just fill that in.
Four. Wait, how'd you do it? Show me. Show me. 4. Can you turn it down and I'll measure? Wait. Dude, you did the wrong angle. No, you didn't. Yeah, you did. Look, this is the big.
You don't have to measure any angles. You measure the sides.
Length 4. Same thing. Okay. I'm pretty sure you did the wrong one though. No. This is A and this is A. That's angle A. We're measuring length A.
Don't measure angles.
Yeah.
Measure sides.
Yeah. Now write down B. It's 6.5. I'm pretty sure you're doing it wrong. Because like it's the big.
Oh my God, are you two gonna fight?
No.
You sound like it. Just measure the sides.
Let me tell you. What do you think?
It's an honors math class. All you gotta do is measure 3 lines.
We're measuring small A, not big A. Oh, okay, that makes sense. We're measuring small A. Calm down.
Wowzers.
6.5. I put it. the other next one. What do you have first, D? Yeah. So
You already done? Or did you bother?
12.2, hurry up. 12.2, write it down.
Okay, this isn't going to work for me. Okay. I do all the work. Just write it down.
I did.
Good. All right. How long is side A?
4.
That should be enough time for everybody to have written. How long is side A? 4. How long is side B? 6.5. How long is side C? 7.8. It's fine. Relax. How long is side D? 12.2. How long is side E? 10. How long is side F? 6. All right. Now, then I asked for you to do the length of side A divided by the length of side F. Why did I want you to use A and F? Pardon? Because they are in the same location on the triangle. Yes? So A divided by F is 4 divided by 6. Yes? Which we all know to be 0.67. Right? Right? Right. Now, B and E. 6.5 over 10. What decimal do you get there? 0.65. Right? And C over D, 7.8 over 12.2. To get what decimal? 0.63. Now, what do you notice about the three decimals? They're very close, aren't they? If we had perfect measurements, what would these three decimals be? Point whatever. They would be exactly the same. All right? These ratios would not change regardless of triangle size. Does everybody understand that? I can draw a triangle on the surface of the world that goes from Vancouver to the North Pole to Bangkok, Thailand, and I can use that measurement from that real life situation. I can draw it on a piece of paper and use those measurements to decide how long the real measurements are. Does everybody understand that? It's how we do blueprints. It's how we do maps. It's how we do everything. We use the concept of similarity, which is based on ratios. Is everybody okay with that? This whole unit is based on ratios, making fractions and decimals. Everyone's cool? Now, the only rule you have to know is this only works if the angles are what? The same, okay? No matter how big the triangle gets, if the angles don't change, the ratios won't change. Everybody understand? So, if the angles are the same, then this is true. Everybody okay? You can draw a triangle this big on your piece of paper and use that triangle to tell you how far the moon is away from us. As a matter of fact, they actually use this math to tell how far stars are away from us. Okay? That's how powerful the triangle is and how powerful trigonometry is. We can use it to measure distances like that. Everybody cool? Okay. Now, I'm going to come back to this shape. Now, you guys do not have a protractor. Some of you do, I heard, and I was just joking, it's not a geek check, because of course I keep a protractor right here in its own little case, like a holster, so I can get a protractor out whenever I need it. But of course, now that I've done this joke, I can't find my protractor. It would have been so much cooler if I actually had it where it was supposed to be. I just had my protractor when I was bugging Bronwyn about having one in her locker and saying it's a geek check. But it's not a geek check because literally right in front of me. There's a Twilight Zone ad or episode like that. How many of you have ever gone into a room with, for example, your keys, put them down, walked out of the room, gone back in, and your keys aren't there? And then you leave the room and you come back in and there they are. Has this ever happened to any of you? Of course your keys were there all along. You just didn't register they were there the second time you came back, right? There's a Twilight Zone episode that says the guy in the episode, his whole life was a movie. So he walks into a room and it's a movie set. And his keys are waiting there for him. And then he leaves the room and somebody who's working on the movie takes the keys accidentally because they think the next shot there's not supposed to be keys there. And then the guy comes back and he's like, where are my keys? Then he leaves and then everybody who's making the movie runs, oh my God, his keys. And they put him down and he comes back in, my keys. Very Truman Show thing. That's where they stole the idea from, actually. If you haven't seen The Truman Show, it's a great movie. Jim Carrey's first good movie. If you haven't seen it, see it. It's really cool. But anyway, it's based on that Twilight Zone episode. And that happens to me all the time. And it will start happening to you more and more as you get older. Ask your parents. There's a comedian who says that where old people store their memories is their ass. Because what happens is they walk into a room, they're like, what am I doing here? I can't remember. Then they go back to the other room and they sit back down. As soon as their ass hits the chair, then they remember they got to go back and get it. Happens to me all the time. I walk in, I look in the fridge. I don't even know why I'm here. Close it, leave, go back, sit on the couch. Oh yeah, I want some iced tea. Anyway, you don't have a protractor, so I am going to measure for you. Of course, you all know how to use a protractor. Angle A is 30 degrees, right? Now, because angle A is 30 degrees, and we already know that all the ratios are the same, that automatically makes angle F what? 30 degrees. Excellent. Angle D is 95. So what does that automatically make angle C? 95. Now, without measuring angle B or E, what is it? $55. Is everybody cool with that? Everybody knows what the people who set a number there did to find that without measuring. Everybody knows triangles always equal 180. Yeah? Everybody knows that? Okay. Now, here's the next thing that's important to recognize on every triangle. What's the biggest angle that we measured? That was the most graceful thing I've seen in a long time. That was lovely. What is the biggest angle on this triangle? 95. What do you notice about the biggest angle and the side that it is opposite? It is the biggest side. Everybody see that? Biggest angle is always across from the biggest side. Now you already know that from the hypotenuse, right? Because the 90 degrees is the biggest angle, the hypotenuse is the biggest side. But a lot of people don't bother going one step further when they're discussing hypotenuses and right angle triangles, that it applies to every triangle. Okay? What do you notice about 30? Smallest angle, what's it across from? Smallest side. And the middle angle is across the middle side. Cool? Everybody got that? It's something that is very useful to you later on. It's not something in the 10th grade I would test you on, but it's something that will help you later on when you're doing work, having that knowledge. Okay? Because a great many of you will do a whole bunch of work, tell me an angle, and it can't possibly be that answer because it's across from the biggest angle and you're telling me the side is smaller. Picking up what I'm putting down? Okay? When you get your test back, you will notice that some of you think that this side is allowed to be longer than this side. Some of you will find that when I give you your test back. So everyone's cool with this? Yes? Okay. What time is it? 1:49. We're going to go on. We're going to do it. Now, how many of you in the 9th grade in this room, in this building, actually did trigonometry with Mr. Keeley or Mr. Fujimura? You actually did trig. You didn't just do some work with triangles. You did trigonometry. Okay.
Were we in the same class? No. We had a first semester.
Okay. Elma's brain remembers doing it, right? So other people may or may not. So we'll rock it through this. It'll take 2 seconds, and it might jog your memory. Okay? All right. So, following my instructions here, most of you have a ruler on you. Draw these lines. Connect A to D, A to H, and then the vertical lines. I, of course, have a fun straight line tool here. So I get to do that right now. So I'm going to connect that in blue. What? Yeah. So? Sorry, OCD man. Relax. Ooh, that guy, he's a weirdo.
Somebody stole it. Not mad. Legit? Dude, it's like the best. Yeah, it's the best eraser. And someone.
Oh, your pencil eraser?
Yeah.
I will keep my eye out for a barrel, and if I see it, I will terminate with extreme prejudice. All right, everybody cool? And then, of course, we do the vertical lines. Easy peasy, lemon squeezy. BF. Oh, good gravy. Gravy is good. Oh, hey, funny story. Yesterday, we all know what happened in the foods room, right?
Yeah.
Well, I went home last night, and I was telling my wife all about the... Oh, good gravy. What have I done? I was telling my wife about the what happened, and while I was telling her, guess what was happening in my kitchen? A fire. Ah! My kid was like, Dad, are you telling a story about a fire at school? Yes, I am, son. Dad, yes, son. You should go to the kitchen. Why, son? The kitchen's on fire. Because I was making stir fry. And to make stir fry, of course, you all know you need to have an extremely hot pan to do it properly. But you also need to actually put something in the pan once the oil hits the pan. But I was talking. Like I do now, I get a little sidetracked. Have my little pot of oil there, like a cooking show, ready to pour it into the pan. So I was talking to Catherine. Oh my God, so there was this fire and the kids yelling, blah, 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 blah. And she walks out of the room and I'm like, and then, and I follow her. And St. John comes in the other door. Dad. So yeah. Oh, go away, stupid. Okay, anyway, screw this. I'm going to draw it freehand. Shut it. Okay, so This is key. What is the distance from BF to AF? So you can count them on here, right? How far is it from BF to B to F? 3. How far is it from A to F? 4. Cool? All right. So that is going to be BF compared to AF is 3 to 4, right? That's how one way to write a ratio. I told you this whole unit's about ratios. What's another way to write that ratio? As a fraction. I saw Marin say the word. 3 over 4. What's another way I can make that a value? A decimal. 0.75. Does everybody see the things disappearing, right? It's not just me, is it? It's happening, right? Okay. I'm just going to shut this down for a second. Do this again. Here we go. Do that for the next 3, because you guys have it on your piece of paper. Do CG, AG, DH, AH. Because I don't know what's going on here. All right. So CG is 1, 2, 3, 4, 5, 6, 7, 8. Oh, wait a minute. C is in the wrong spot, or D is. One of them's in the wrong spot. 8. And AG is what? 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. This should be 9. My drawing is bad. CGAG is 9 over 12, which is what? CGAG is, again, 0.75, yes? So what's DHGH going to be? 15 over 20, which is, again, 0.75. I'm going somewhere with this. What do you notice about this triangle, and this triangle? What's the only thing they all share? No, because these ratios have the same value, but they're not the same ratio, are they? Because one's 3/4, one is 9/12, right? So it's not the ratios. There is one thing that all 3 triangles share. What is it? Bronwyn. It is the angle. Which angle? Angle A is the only one that is in all 3. Does everybody understand that? Everybody cool? All right. So our general statement is regardless of side length, the ratios between sides stays the same. That's point 1. Oops. Point 2, we notice that angle, I'm going to use the symbol, angle A is present in all triangles, regardless of size. So let's pretend I continue this triangle all the way back to Patricia and all the way out into the hall. What's angle A going to be? The same, whatever its value is. Everybody understand that? What if I take that line all the way to, let's see, what direction is that? That is north-ish. I draw that line all the way to Bella Coola, and I draw this line all the way to Williams Lake. What's this angle going to be? The same. Everybody understands this? Okay. This is called the tangent ratio. And you will recognize it from your calculator if you've done some trig as the tan button. Many of you have seen that button. If you haven't done trig, you don't know what that button is for. You are now going to learn. Now, is this ringing bells for some more people than Elma? Yeah, a couple people are remembering this now? Okay, good. That means I can go pretty quickly with it. And it holds true for all right angle triangles. Okay, please highlight right angle. This only works with right angle triangles. Are there more triangles in the world than right angle triangles? Of course there are. And eventually we're going to get to how to do math with unright angle triangles. But right now we're stopping with right angles. Everybody cool? Okay, now we get to the worst part of trigonometry. First thing I want to talk about is this. This ratio, you will notice, is 3 over 4, or 9 over 12, or 15 over 20, right? What do you notice about those? I always used 3 and then I used 4. 9, then 12, 15, then 20. And I was working from angle A, yes? Now, I've already told you that the tangent ratio is always the same. And I always use this number that is across from A is the numerator. In this unit, what is the word we are going to use instead of across? Opposite. So the tangent ratio is the opposite value. Now, why did I use the word value? Because it might not be a number. It might be unknown. It might be an irrational. It might be a root. It might be whatever is there. The opposite value is the numerator of that fraction, that ratio. Cool? And the denominator of that ratio, you'll notice, is this one. It has a name. Those of you who've done trig, what is the name of the one that's right beside? Anybody remember? Adjacent. The adjacent value. Okay? It's always that. Now, here's the thing. Every angle has a tangent value. And they're different. 3/4, 0.75, is the tangent value of this specific angle. Every other angle will have a different value. Understand? And that makes sense, doesn't it? Because as I change the angle, I'm going to change the distance of the opposite, aren't I? Right? Everybody cool? So, that's the theory. Now we're going to actually do the practice. Everybody needs their calculator out. Everybody needs a couple of things on their calculator to be visible. I'm going to get my calculator visible. Are any of you working from one of these fancy schmancy calculators? Is anybody using one of the big graphing calculators? No, no one is? Okay, good. Everybody else on your screen, on your calculator right now, look and find a letter D. Is it visible? If there is no letter D visible on your screen, you have either an R or a G, put your hand up. What do you have? On the screen, not a button. On the screen. On your screen, you are looking for either D, E, G, or a letter D. Does everyone have that? What are you putting your hand up for? You're only supposed to put your hand up if you don't have it. Does everybody have that? Okay. You cannot do trig in grade 10 if you don't have a D on your screen. Okay, so that's the first thing. Always, you're in degree mode. If you ever find your calculator without a D, you need to push the button DRG until you have D showing on your screen. The D stands for degrees because we are going to be working in degrees. Does everybody have that? Whether you do or don't, I'm about to find out if you do or don't. Everybody is going to do A right here. Now, if you have a calculator like mine that prints the name of the button you push, then you are going to hit tan, then 35, then equals. Tan, 35, I have to close the brackets, equals. Now, you guys should have a different number than that. Do you? Good. That tells me that my calculator is in the wrong mode. So I got to fix mine. It'll just take a sec. Now, when I go tan 35 equals, all of you should have gotten 0.700. Now, some of you have a calculator that doesn't print it this way. You have to reverse the order. You have to do 35 tan. And you won't need to hit the equal sign. Can everybody make their calculator show 0.700? Everybody can? So you know how your machine works, right? It's a big pain in the butt for math teachers because everybody's got a different calculator. Now, what's tan 15? Use your calculator, tell me what the decimal is. .267. Everybody cool? Everyone's able to do this, yes? Okay. What's tan 45? 1. Everybody with me? Is everybody good? So, underneath here, you should have a bit of space. Do you still? Just a tiny bit, yeah? What does this mean? Oh, that's a horrible drawing, Mr. Myers. Draw a triangle. Make this angle 35 degrees. This side over here is what? Opposite. This side here is adjacent. Everybody cool? What does that mean? That means O divided by A equals 0.700. Everybody got it? That's all your calculator did there. Because every 35 degree angle, no matter how big the triangle is, when you divide whatever number is there by that, you are always going to get 700. That's how your calculator knows it. Is everyone cool? All right. So what does it mean for B? If it's 15, then O divided by A is going to equal 0.267. Is everybody cool? It doesn't matter the size of the triangle. Whatever that measurement is, divided by that, if it's 15 degrees, is going to be 0.267. Now, I do this because 45 is a special one. Okay? If this is 45, what does that make this? 45, right? Right? 90, 45, and 45. Everybody cool? What do you know about triangles if two of the angles are the same? What does that tell you about this side and this side? That they're the same, doesn't it? So if your angle is 45, O and A are the same, aren't they? So O divided by A is the same as O over O, or A over A, which equals 1. That's why 45 is 1. Everybody cool? It's going to come into play a lot in the near future, but right now, I just want you to be aware that it's not always a crazy decimal. Everybody good? Okay. Now turn your page over. And now we're going to go the other way. Now, the question we had on the front, that was our ratio, wasn't it? But we don't know how big that angle is, do we? Your calculator can tell you. Again, you need to push. Tan gets me the decimal. If I have the decimal, tan gets me a decimal, which is the ratio, but decimal gets me back to the angle by pushing second tan, or shift tan, or some of you INV tan. It depends on your calculator, but you follow the same rules as you did to find the tangent. Everybody cool? So, if you have a forward calculator like I have, this guy, I do exactly what I did. I go second tan, and it makes this little tan -1. Then I put in 0.75, and I close my brackets, and my calculator tells me it's a 36.86 degree angle. So I write tan -1 equals 36.86. If you have does anybody have the backwards calculator where you had to push 35 tan? Oh, there's some in every class. Okay. So you got to do it the opposite way around. You got to go 0.75 shift tan. So if you've got a backwards calculator, you got to do your 0.75, then shift, then tan, and you should get the 36.86. Can everybody do it? You can't?
I don't know how to do it.
Does your calculator print like mine, or does your calculator not? When you hit the tan button, does it put the word tan on the screen?
Yeah.
Okay, so you punch it in just as you see it. You go shift, tan, 0.75 equals. Everybody got it? Okay. Do tan C first. What's the answer? 68.8 degrees. Okay, 68.1. Everybody cool? Now, what happens when you hit tan B? Shift, tan, oops, clear. Shift, tan, -1.23. -50. Can I call that 51? Is that okay with everyone? Just to make my life easier? Does everybody see that? That makes very little sense, doesn't it? How can you have a negative angle? Right? Here's how it works. And we're going to do a lot more with this later on. I'm just going to show you this once. Circle, yes? How far is that in a circle? How many degrees? 90. 90 positive, because we're going up from 0. So where do you think 51 negative is? The opposite way. So I go this way, 51 degrees. Now you guys are smart kids, right? How many degrees is it all the way around to here? 360. But I'm going 51 degrees short of that. So what is this angle right here that I actually get to? Going all the way around just to here. 360 minus 51. 309. Now, if you check the tan of 309, guess what it's going to be? Negative 1.23. Cool? We're going to do more with that later. I just want you to be aware that negative angles exist. Because up until now, I'm betting none of you have ever thought or seen a negative angle. Scarlett. Tan 309. Negative 1.203. Negative 1.23. Try it again. When you do tan of negative 51 or tan of negative 1.23. Yours went right to 309? Forgot to put shift tan? Okay. Guys, please notice how persnickety trigonometry on your calculator is, right? That's why I spend so much time at the beginning actually drawing out the triangles. Because if you hit a wrong button, you're going to get the totally wrong answer. But it's going to look like the right answer, isn't it? Because all the numbers are so big and ugly. I'm just going to write it down. Right? So you got to know what you're actually doing. Is everybody cool? Okay. Now, what does this say? For any specific angle. Any specific angle means the acute ones. So the acute angles are the ones that are less than 90 degrees. In our math, right now, we are only going to deal with angles less than 90. Okay? The tangent ratio compares the opposite to the adjacent. How do you decide what's opposite and what's adjacent? It depends on what angle you have. And this is where trig causes trouble for kids. Okay? Did this triangle draw on your guys' paper? Do you have ABC here? Yes? Okay. If, here I am, Mr. Myers, big muscles, lots of hair, so totally true, glasses, there I am. If I'm at angle A, and I want the tan of A, the tangent is opposite over adjacent, yes? So what numbers would I put in there? 12 over 5. Cool? If I'm up here at A. What if I move down, I slide down the hypotenuse to B. Now what's the tan? 5 over 12. For some reason, that is disappearing. That concept makes trig difficult for people. Okay? Don't be those people. Right? Everybody understand? Where you are affects the opposite and the adjacent, which only makes sense, yes? If I'm in Canada and I look south, I see the United States. If I'm in the United States and I look south, I see Mexico. Understand? Where you are depends on what changes what you're going to see. But kids, when I teach them trig, this causes them much grief. Everybody cool? So we got A, B. Now, what are the angles of A and B? So I have my decimals, don't I? Or do I? All I have are my fractions, yes? Everybody with me? So if I want the angles, soon as I see the word angles, that was supposed to highlight, as soon as I see the word, thank goodness I got a new computer because it works so well. As soon as I see the word angle, what do I need on my calculator? Tan or shift tan? Which one finds an angle? We just did 6 of them. We did some tans, we did some angles. Which one? Shift tan, right? But I needed shift tan, which I am now going to start writing as tan -1, except it's going to come out as lan -1 because my computer isn't working. I don't know why. Tan negative. You know what's really funny? Nothing. Tan -1. That's what I'm going to start writing now instead of shift tan, right? Tan -1. And then in our previous examples, we had a decimal, didn't we? But I don't have a decimal here. I have a fraction, don't I? So how can I punch that into my calculator? I would go tan -1, shift tan, bracket, 12 divided by 5. You guys see how cool I'm staying? Because you know my laptop last year didn't do that ever. The one that's not good enough to use anymore. The one that I had to give back for my nice new one. Because my new one works so well. So that is 67.3. Is everybody cool? Okay. So now do tan B. Or no, sorry, shift tan B. So it's shift tan bracket 5 divided by 12 bracket equals. Yeah, because you can't read it. Because why would my $2,000 machine work? That's no use to anyone, is it? You know what always works? The whiteboard. So, you know? Yeah. Yeah, boy. Tan -1b equals shift tan bracket 5 divided by 12 bracket equals. Yeah, that worked. Wait. So you guys, so it's like real life? It just disappears. So everybody cool? What's the angle of B? Pardon me? 22.6. Excellent. Now, if my computer was allowing me to scroll down, which you can quite plainly see, oh, it lets me scroll up but not down. You, of course, should write down what I said to write down. what you had to type into your calculator. So how you get this answer, because it's a little bit different. Okay? For me, I need to hit second, tan, bracket, 5 divided by 12 bracket equals. Some of you won't need the bracket. Some of you won't need some of you will say I and V. Some of you will say shift. Some of you write down what you need to type. Second land bracket, 5 blank, 12 bracket. According to, Bill Gates. Maybe my battery is getting low. Maybe that's what it is. Let's try that. Holy crap. Maybe it's that. No, it still won't scroll. So now you guys should be able to do these, right? Everybody cool? That's your job. Do those 3. I know it's easy. There's X. So that's the one you're working on. Yo. Yeah, the bell's going to ring in like a minute, but you're welcome to go now if you need to. All right, so obviously we'll go over our test tomorrow. Anna, can you stay for 1 second so we can discuss the test situation? Is there anybody else in here that didn't write the test yesterday? Right there. Oh, because I erased it because it disappeared. 5 divided by 12 equals. But I think your calculator's backwards, isn't it? So you would have needed to do this. Bracket 5 divided by 12, bracket, shift, tan, and you might have to push equals. That's the way you got it in. Okay? That's why I want you to write down what you have to type in. Okay? Because it's not what I type in, and it might not be what Christina types in, which might not be what Danielle types in, right? That's why I want you to write it down. Okay? Your homework is to make sure that Pythagoras sheet is done and to do those 3 questions. That's it. Because I am going very slowly with the beginning of trig. I love trig, by the way, in case anyone cares. It is my absolute favorite math.